Welcome back, everybody. We are going to complete our 3.2 function notes today. We left off talking about discrete versus continuous. And so let's take a look at number 13 and talk about, is this discrete or continuous? So we have tickets for a museum. If we have tickets for a museum, you either have a ticket or you don't. You don't get a half a ticket or a third of a ticket or a fifth of a ticket. So that would make this discrete. Because each customer can have a maximum of 4 tickets, the domain then you could have 0 tickets, 1 ticket, 2 tickets, 3 tickets, or 4 tickets. Those are our options. Now, if I wanted to graph this, I could make an XY table, and we said our domain is 0, 1, 2, 3, and 4. What we would want to do is plug each one of those into our equation, which is 15.95x, because it costs $15.95 for each ticket that you buy. So if we had 0 tickets, then we would have $15.95 times 0, which is 0. If we bought 1 ticket, then we'd have $15.95 times 1, which is $15.95. 2 tickets, $15.95 times 2, which would cost us $31.90. And then $15.95 times 3, which is $47.85. And last, $15.95 times 4, which is $63.98. Or I'm sorry, $63.80. And so there's our table that we would use to plot our graph. Plotting our graph, we do have decimals, so we're probably going to have to do some estimating. And we're going from 0 to roughly about 64. So here's our 4, and our x-axis is tickets. And then I think I am going to go by, let's do 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So we have 0 tickets, $0. 1 ticket is $15.95, just a little bit more than 15. 2 tickets is $31.90, so roughly about 32. 3 tickets, $47.85, so about 48, maybe roughly about right here. And then 4 tickets, just about 64. So let's talk about this. Should we draw this line to connect them, or should we not draw the line to connect them? And the answer to that is no, we should not draw the line to connect these dots. And the reason why is because this was a discrete function. Discrete function means I can't draw the line, because if I draw the line, that means I can have any number of tickets in between 0 and 1 and in between 1 and 2. When we said we can actually only have 1 ticket, 2 tickets, 3 tickets. So we do not connect the dots when we have a discrete function. So you try number 14 with the DVDs. pause this and come back when you've tried it. Right, a cereal bar has 130 calories. The number of calories consumed is a function of the number of bars eaten. So is this a linear function? And I would say yes, because the rate of change would be constant. You eat a bar, it's 130 calories. You eat a bar, it's 130 calories. You eat a bar, it's 130 calories. So every bar, every 130 each. Is this discrete or continuous? Well, the question is, can you eat part of a cereal bar and then leave the rest for later? Yeah, actually you could. So that makes this continuous. And again, because I can eat a third of a bar, an eighth of a bar, 3/5 of a bar, I can eat however much of that cereal bar I want to. So that makes it continuous. The domain then, we could choose to eat 0 bars and then anything more than 0. We can't have negatives, right? Because it doesn't make sense. You can't owe a cereal bar to your stomach. But you can choose to eat no cereal bars, or you could eat a half of a bar, or 7/9 of a bar, a full bar, and so on. So our domain is going to be bars is more than 0. If I again want to make a little table to get me started on how to graph this, I'm going to do 0, 1, 2, and 3 bars. So at 0 bars, we would have 0 calories. If I ate 1 bar, I would have 130 calories. 2 bars would be 2 times 130, which is 260 calories. 3 bars would be 3 times 130, which would be 390 calories. So going with those values, number of bars, 1, 2, 3. This will be number of calories in going by 100s. So 1, 2, 3, 4, 5, meaning 100, 200, 300, 400, 500. So plotting this, 0 bars, 0 calories, 1 bar, 130 calories, so estimating about right there. 2 bars, 260 calories, a little more than half. 3 bars, 390 calories, which is just under 400. And do we connect these dots? Yes, we do, because again, we can choose to eat a half a bar. We can choose to eat 3.99999 bars. Any amount of the bar that we want to, we can eat. Let's go ahead and have you try 16 and 17. Pause while you're trying it and then come back and we'll finish up our notes. All right, writing real life problems. And is the domain discrete or continuous? Well, in number 18, because we're only graphing dots and there's no line connecting the dots, this one would be discrete. So maybe we have 6 lollipops and there are 6 kits. So you're going to give a kid a lollipop. You can't give them a part of a lollipop. You either give them the lollipop or you don't. And so every time you give a kid a lollipop, you have less lollipops to give. So this is lollipops, and this is kids. For 19, this is continuous because we drew a line here. So maybe we have 6 cups of juice. And we can drink, let's see, cups of juice. Remember, you can choose to drink a whole cup or not a full cup. And this is the number of hours that we're drinking our cups of juice. So we can drink a third of a cup in 20 minutes. We can drink an eighth of a cup in 5 minutes or whatever. So that's why, because we can have different pieces and parts, it's continuous and we connected these dots. Go ahead and finish this out with trying the last 2 problems, and we'll see you in class tomorrow. Have a great night.